Hi, Precalc students. This is 323 graphing logs. Please take notes in your notebook. You won't remember this stuff if you don't write it down. So make sure you write down all this information on a new page in your notebook, and then in class you're going to apply this stuff. Okay, so write down that this f of x equals log base 2 of x is the parent function for logarithms. So that's super duper duper important, all right? So make sure you get that done and know that that's the parent function. So we're going to kind of look at that one now. So first let's find the inverse because I want to prove to you the relationship we talked about in class with exponents and logs. So remember that the inverse of the log is going to be the exponent version of it. So it's going to be y equals 2 to the x power, all right? And so if we find the domain and range of that inverse, maybe let's graph it first, actually, and I'm going to make a table. So I'm going to skip to number 3 here, okay? And we're going to make a table of values from -3 to 3 for x, right? So I'm going to go, x, y, and x is -3, -2, -1, 0, 1, 2, 3, all right? And then our y values, we're going to just plug them into this equation here, right? So 2 to the -3rd power is 1/8. Let me go ahead and make this blue because it's 2 to the -3rd. 2 to the 3rd is 8, but then it moves to the bottom because it's negative, right? And then 2 to the -2nd would be 1/4. 2 to the -1st would be 1/2. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2nd is 4. And 2 to the 3rd is 8. So that is the points for your exponential equation, right? So this is for y equals 2 to the x. All right. And then let's graph it and look at what it looks like. So if I do my graph, let's see, let me get a pretty graph for you guys as best I can. We got to make sure we have 8 on the x-axis. So let's see. I'm going to, or on the y, that's the y-axis. Sorry, we're good. So we need to go like this, right? And then I'm going to do -1, -2, -3, 1, 2, 3. And then this way I need to go up to 4, 5, 6, 7, 8. If you're using graph paper, it would be even better because you can make sure that your graph is really pretty. So I'm doing the best I can here, freehanding it. All right, so let's graph these points. -3, 1/8 is going to be a little bitty point. Let me make this one blue since that's what color I made my equation. 1/8 is really close to 0, right? 1/4 is a little bit bigger. 1/2 is slightly bigger. 0, 1 right there. 1, 2 right there. 2, 4, and then 3 and all the way up to 8. So exponential growth, right, you guys? So it's increasing exponentially. Okay, that looks pretty nice. All right, domain and range, let's talk about it. So domain, it's going forever in both directions, left and right. Yeah, so the domain of this one would be all real numbers, right? So remember we say that by going -infinity to infinity. Okay, and then the range is going to be only the positive y values, right? There's nothing below down here happening on the blue curve, right? So because of that, we say it's going to approach 0 but never actually equal 0 because there's no way you can get 2 raised to any power to equal 0. It can get really close with negative exponents, but it's not going to actually touch 0. So we're going to say it doesn't include 0. 0 is like our asymptote. And it goes to positive infinity, okay? So that is for your exponential curve. So I'm going to go ahead and label this just so I don't forget which one this is. This one's 2 to the x power, and then this is my domain and range for that graph. Okay, now number 3 we did, that's the table. Number 4 says reverse the table and graph the points. This will be y equals log base 2 of x. So I'm going to do that in green. I'm going to take all these points and I'm just going to flip-flop them, right? So we talked about this today, if you were with me. So the y's become the x's and the x's become the y. In other words, the first point that's negative 3 comma 1/8 will be 1/8 comma negative 3, right? And so on and so forth. So I'm just going to flip-flop them. 1/4 negative 2, 1/2 negative 1, 1, 0. I'm going to have to write really small here. 2, 1, 2. Oh, I almost forgot to flip that one. Sorry. 4, 2. And then my last point would be 8, 3, but I can't, maybe I can squeeze it in. Let's see. 8, 3. Sorry if you can't see that very well. So just flip-flop all those points, right? And now let's graph those points. Graph the points. This will be log base 2 of x. And I'm actually going to make that graph green just because black's not going to show up as well for us. Okay, so this is going to be log base 2 of x. So 1/8 and negative 3 this time is going to be really close to the y-axis, right? So it's going to be like right about, let's see, about right there. And then it's negative, or 1/4 and negative 2, right? And then 1/2 and negative 1. Then 1, 0. Then 2, 1. Then 4, 2. And then 3, 8, or 8, 3, I don't think I can quite fit on the graph, guys. I only went to 7 here. So just imagine that that last point that's way up here is going to be over here somewhere, but I just can't quite go far enough, so I'm not going to do it. All right, and then our curve, let's connect them, is going to this time go along the y-axis, right? Because it's the inverse. So instead of approaching the x-axis like the other one does, it's going to approach the y-axis. Okay. So hopefully you can see that those guys are reflecting each other across a diagonal line, which is what I want you to do in number 5. Draw y equals x. This should be the reflection line. So y equals x, remember, is just the parent function, linear parent function, and it looks like 0, 0, 1, 1, 2, 2, 3, 3. I'm trying to make it as good as I can on this thing, sorry. Negative 2, negative 2, negative 3, negative 3. Okay, so we get the general idea. And for this one, I'm going to actually cheat and use my little line tool so I can make sure I get a really straight line for you guys going through there. And then if you'll actually go ahead and dot that line, right? So that way you know that it's just to demonstrate that this is a reflection line. And so you should see that the blue curve and the green curve are reflecting across that line. Okay, so let's label everything. That's y equals x. The green curve is y equals log base 2 of x. And then, guys, what do you think the domain and range is going to be of y equals log base 2 of x? This is the last question. The domain and range, hopefully you're realizing, is just going to be the reverse of this, right? So now notice that my y's are the ones that are going up and down forever. So my range is my domain from the last one, right? So you're just going to switch the domain and the range, and I'm going to do it in yellow. Hopefully you can see this. So the domain is going to be 0 to infinity because it's only going this way, right? It's not on this side at all over here. So no negative x's, right? And the range is going to be all real numbers. So it's just the inverse of the exponent, all right? So make sure you have that all down really, really nice and solid. Okay, next I want you to do this part on your own. You're going to apply transformations and graph. So you can use Desmos for the graphs, no problem. But before you do that, I want you to, let's just talk about it and see, hopefully we remember what this stuff does to these, right? So when there's a 5 in the front here, what does that do to the log base 2 of x? So that's your parent function. The 5 in the front, remember, is going to be a vertical stretch by 5. So you should see a much steeper increase here, right? In other words, you guys remember we talked about today, it's multiplying the y values by 5, all right? So write that down if you need to, multiplying y values by 5. What is it happening on this one? Sorry, I'll keep my colors consistent so we can keep track of all of them. On the red one, what is that -3 doing to the graph? So notice it's not inside with the x like it is on letter C. So that is going to be a k value. So it's going to affect vertical shifting. So it's going to vertically shift down 3. We've done this every chapter so far, and you did it a lot in Algebra 2, so hopefully you're feeling pretty comfortable with these transformations. Okay, this one is inside with the x, so it does the opposite of what we think it should do. It moves horizontally, and it just moves, so we call that a horizontal shift, right? And it's going right 3. The green one, the only difference is it has a negative that's on the outside. So when a negative is on the outside, that is going to flip across, or sorry, reflect down. So it's going to reflect the y values to be the reverse. So it's going to flip it down, right? So instead of it going like that, it's going to go like that, okay? You should see this on Desmos when you check yourself in a second, hopefully. Okay, now this one has 3 things. We got that, we got this, and we got that, right? So remember that the negative does the same thing as letter D. Letter D was a flip down, or you could say a reflection across, and this is way more mathematical, the x-axis, because that's going to change the y values. And then the inside, remember, does the opposite of what you think, just like letter C's graph. So this one's going to go left 4. And then this one right here shifts it down 1. Nope, sorry, it's positive. It goes up 1. Up 1. All right, and then go ahead and graph them, you guys, and check that what I wrote down just now is all correct. I would also include the graph of the parent function just so you have a comparison. So when you graph, make sure you graph this one as well. And then I would graph them one at a time with it. Otherwise, it gets really messy and it's hard to tell what's what. And then please challenge yourself to try to find the domain and the range of each. And remember, you can use the domain and the range of the parent function, which is this stuff, as a guide, right? And so if you're shifting it up or down, it's going to affect, you know, range. If you're shifting it left or right, affects domain, and then the way that it goes might affect either one. So do the best you can with that, and we'll talk about it more when I get back, okay? Thanks, you guys.